CMV, statistics is much more valuable than trigonometry and should be the focus in schools. Just throwing in my 2 cents as an engineer, but trigonometry is extremely vital for almost all modeling situations. The transcendental functions and the connections established through the Pythagorean theorem are essential when trying to apply vectored mechanics in a 3D world. The basic knowledge learned from the geometrical basis of shapes as well as proofs also can be a bit useful when doing finite element analysis. I don't think it should be stressed as much, as most of it applies to theoretical math problem solving, e.g., what is the mathematical proof for the ideal packing order for spheres in a cylindrical container? Edit. Also, trigonometric functions show up basically everywhere. Alternating circuits, rotation matrices, wave functions, literally every physics field and its grandma has some use for these functions. Honestly, I would argue that trigonometry is one of those things that cannot be escaped if pursuing any STEM field, maybe not medical. There is also the contention that not knowing trigonometry can be crippling or a major setback for most prospective engineers looking to further their education. Edit 2. I just want to make a key takeaway that I saw from this line of thought. Education is too generalized for the vastly unique populace. Saying things like stats, geometry, or vice versa isn't the solution. Edit 3. Just sharing some information about why stats might require trigonometry to learn. Basic stats is not advanced stats. Let's make that distinction clear. Basic stats is intuitive and most middle schoolers have a decent understanding of it. Advanced stats involves multiple extremely conceptually difficult topics, and many of which apply transcendental functions to model them, e.g., the normal distribution. Just for normal distributions, you need to understand continuous probability density functions, how to integrate that probability density function, the theorems that formulated the normal distribution, modern applications to actually use this knowledge, coding languages like R. The stuff I mentioned is tied to trigonometry in the proofs, which are the foundation to them. I would not say that trigonometry is a requirement to learn this knowledge, but if you find yourself looking back at the why time and time again, you need trigonometry. The value provided by trigonometry, along with the rest of mathematics education, is a hard journey in learning how to reason deductively and objectively utilizing abstract concepts. Statistics is similar in this regard, but with one important distinction: it is inductive. Through this lens, I would argue that we have an immense importance in producing an education system that trains people to effectively use deduction and induction in concert with each other. Therefore, I kinda reject this comparison of trig and stats, as they are kind of like apples and oranges. Never mind the fact that statistics education, generally, sucks. But that's neither here nor there. I've heard some valid arguments for replacing things like trig with other, more relevant abstract deduction type subjects like computer programming and software design. I like the kind of thinking your CMV presents. Just if we replace trig with something, it should be something that stretches the same kind of mental muscle. Logic should also be taught so that people learn the difference between deduction and induction. That's over most people's heads. I am a high school math teacher, and I want to address a couple of things your post assumes that I don't believe are true. I'm not aware of a national standard that requires statistics. First is that high school curricula focuses on trigonometry at the expense of statistics. The Common Core State Standards, used by the majority of states and territories in the U.S., calls for the following topics in statistics and probability. A few I'd like to highlight from that list include: summarize, represent, and interpret data. Make inferences and justify conclusions from sample surveys, experiments, and observational studies. Use the rules of probability to compute probabilities. Use probability to evaluate outcomes of decisions. Although I chose what I believe to be the best summary of the standards, you can see for yourself that the statistics and probability standards are, while low-level compared to the depth of the field, fairly comprehensive and, more importantly, practical for all citizens. Meanwhile, trigonometry as a study lives in multiple areas, although it tends to get sorted into 2 courses. Geometry, which asks students to define trigonometric ratios, solve problems involving right triangles and trigonometry, and apply trigonometry to general triangles. Algebra, which asks students to, in the course of studying functions, extend the domain of trigonometric functions using the unit circle, model periodic phenomena with trigonometric functions, prove and apply trigonometric identities. Now, I will grant that when I was in high school, trigonometry may have been billed as its own course, but the truth is that your typical math high school sequence will include Algebra 1, Geometry, Algebra 2, sometimes called Algebra 2/trigonometry, to indicate that this is the year you study trig, or even better to allow a differentiated course for students looking to take calc, pre-calc, or higher-level courses in high school, followed usually by pre-calc, calc, statistics, and often some number of general math, personal finance, or other type of math-related course meant for students who don't want to struggle through pre-calc as juniors or seniors. This is all also assuming the school in question doesn't utilize an integrated curriculum, wherein the topics aren't sorted into the algebra/geometry silos, but are rather taught in an order that, generally, moves through the algebra sequence and brings up topics in geometry as they are appropriate or applicable. This is all to say that, in my professional opinion, you are overstating the prevalence of trigonometry and understating the prevalence of statistics in the typical high school curriculum. Statistics and probability tend to find their way into at least 2 of 4 years of high school math, making it at least as prevalent as trigonometry, and potentially more so, especially for students who go on to take a statistics elective in high school. Now, as many others have noted, any student looking to enter a STEM field will need to know a lot more math besides statistics skills you have mentioned, so the algebra/geometry sequence I described above is obviously a benefit to them. As for the remainder of the population, I would direct you to the standards for mathematical practice. These are the overarching things that teaching a young person math actually teaches them to do. Make sense of problems and persevere in solving them. Reason abstractly and quantitatively. Construct viable arguments and critique the reasoning of others. Model with mathematics. Use appropriate tools strategically. Attend to precision. Look for and make use of structure. Look for and express regularity in repeated reasoning. Now, one could build capacity for all of these things through a statistics-only curriculum, but if you're looking to build these 8 skills over a 12-year academic career, not only would the statistics be super thin, but it would be impossible to advance a good number of those topics without a foundation of competencies in algebra and geometry. For most people, algebra, geometry, trigonometry are rarely if ever used after they leave school. Just addressing algebra here, I don't think you understand the main purpose of algebra. Algebra is not about solving complex math necessarily, it's about solving for unknown variables and thinking algorithmically. So, sure, you might not think you are doing algebra, but every time you are forced to rearrange variables to solve a problem, it's because you learned algebra. Every time you have to break a complex problem into smaller steps to solve it, you are using algebraic theories. It's more about complex problem solving than it's about math and numbers. On a further note, it's absurd to think anyone could study stats without algebra. I can't believe you would even mention dropping it for stats. That's like saying people should just learn multiplication and not worry about addition. They are directly related. I first learned SOHCAHTOA in 4th grade, so I was 10-ish. Could you explain to me what a Pareto distribution is in words a 10-year-old can understand? Heck, just try explaining CDFs. I'm not entirely sure your conclusion is wrong. We would definitely benefit from better statistics education in the country. But I think your framework for deciding what classes should be included in a high school curriculum is wrong. Or rather, I think it's missing a piece. High school course requirements aren't just about providing the most benefit for the average student after high school. They're also about making it so that people don't have to decide on their career path when they're 13. Part of the point of the general education requirements is so that someone can enter high school thinking, I'm going to be a historian, and then decide in their junior year, actually, no, I think I'd rather look into a career in engineering and be fine. So you can't just think, is this useful to someone who doesn't go into that field? You also have to think, is it necessary for someone who goes into this field to be learning this now?